Hello and welcome. In this presentation, we will explore the concept of high availability in system design, diving into key principles and best practices for ensuring that systems remain operational with minimal downtime. High availability or HA is a design approach that ensures systems are continuously available and operational, even in the event of failures. The main goal is to minimize service disruptions, providing users with uninterrupted access. To achieve HA, we focus on fault tolerance, load balancing, replication, and failover mechanisms. In system design, we will often encounter two main configurations, active-active and active-passive. In an active-active configuration, multiple systems run in parallel, sharing the load and ensuring continuous service. In an active-passive configuration, one system is active while the other is passive, such standby, ready to take over in case the active system fails. Choosing between these configurations depends on our system's specific needs for performance and redundancy. Load balancing is crucial in any high availability system. It helps distribute incoming traffic across multiple servers to prevent any one server from becoming overwhelmed. There are different methods for load balancing. Round robin distributes requests evenly. List connections routes traffic to the server with the fewest active connections. IP hash routes traffic based on the client's IP address. We can choose from hardware-based, software-based, or cloud-based load balancers depending on our system architecture. Replication ensures that data is copied and stored across multiple systems, ensuring redundancy and availability. There are two common types of replication. Master-slave. The master system handles both read and write operations, while the slave systems replicate the data. Master-master. Both systems handle reads and writes, providing better load balancing. It's important to keep an eye on replication lag, which is delay between when data is written to one system and when it's replicated to others. Sharding and partitioning help scale our database to handle large amounts of data and traffic. Sharding this divides our database into smaller pieces called shards and distributes them across multiple servers. Horizontal partitioning sharding splits the data by rows, such as dividing users by region. Vertical partitioning divides the data by columns, such as separating user data from transaction data. Distributing services across multiple geographic regions can significantly enhance availability. Multi-region deployments help reduce latency by routing users to the nearest data center. It also improves fault tolerance as failure in one region does not affect the availability of services in other regions. For example, traffic can be routed to data centers in the US, Europe, and Asia, ensuring that users from different parts of the world have fast access to services. Failover is a process of switching to a backup system when the primary system fails. Automatic failover happens without human intervention, ensuring minimal downtime. Manual failover requires intervention from administrators during a failure. Key components from implementing failover include health monitoring and automated traffic rerouting to backup systems. Health monitoring is essential to detect and respond to failures promptly. Heartbreak mechanisms check the status of systems at regular intervals. Health checks to help monitor the availability of services, databases, and instances. If a failure is detected, the system can promote standby systems to take over without manual intervention. Disaster recovery ensures that systems can recover after a catastrophic event such as a server failure or data loss. Key elements of DR include data breakup, data backup, regularly backing up data to avoid data loss, failback procedures, returning to the primary system once it's recovered, geographic redundancy, storing backups in different regions to avoid localized failures. To design highly available systems, there are several tools and technologies we can leverage. Cloud providers like AWS, Azure, and Google Cloud offer built-in availability features such as elastic load balancing, auto-scaling, and multi-region deployment. Database solutions like Amazon RDS, Google Cloud Spanner, and Cassandra ensure high availability and scalability. Content delivery networks (CDNs) improve availability by caching content across multiple global servers. In summary, designing for high availability is about ensuring that our system remains online with minimal downtime. Key strategies include active-active configurations for better load distribution, data replication and sharding for redundancy and scalability, failover mechanisms and health monitoring to handle system failures, leveraging cloud services and CDNs for global availability and resilience. That concludes the presentation on designing for high availability. Thank you.